All right, welcome back. Hononegah, Algebra 1, Section 6.1, Properties of Exponents. So Chapter 6 is a bigger chapter. We're going to break it up into just doing 6.1. So this is actually 6.1, Day 1. We're going to have 6.1, Day 2, 6.1, Day 3. So again, we're going to do multiple items here. So vocabulary. Identify the exponent and the base in the expression. Well, the base is the number. So that in this case, 13 raised to the 8th power. So 13 is actually the base, and I shouldn't say that. 8 then is what is referred to as the exponent. So 8 in this case is the exponent. It's the small number. Now, when you put it all together, the expression that represents repeated multiplication of the same factor is actually called a power. So when you put 13 raised to the 8th together, that is actually referred to as the power. So 13, the base of 13 raised to an exponent of 8 is a power, 13 to the 8th. So in the first one here, x is the base, n is the exponent, and x raised to the nth is the power. So 3 is the base, 4 is the exponent, and 3 to the 4th is the power. And the last one, a is the base, 7 is the exponent, and a to the 7th is the power. So it's basically the repeated actual multiplication of the same factor is referred to as the power. First exploration, I'm going to give you the answers here, and then we're going to talk. So 5 to the 3rd times 5 to the 6th. Notice, so I get 5 to the 9th. X to the 2nd, x to the 3rd, x to the 4th, make x to the 9th as well. So what do you notice about the base? When multiplying powers, remember 5 to the 3rd is a power and 5 to the 6th is the power. So when multiplying powers, you must have the same base, and the base does not change. Now, what happens to the exponent? You add. So anytime you must have the exact same base when multiplying powers, and you add the exponents. So add exponents. Can I simplify x to the 3rd, y to the 2nd? The answer to that is no. Reason? Not the same base. So exponent rule number 1, product of properties. The multiplying powers with the same base, add exponents. Keep base the same. Next one. So negative 3 to the 4th times negative 3 to the 2nd. I am going to leave the negative 3, add the exponents. Now, this is one that people usually get wrong. X to the 1st, and there's not usually a 1 there. That's an exponent that's assumed. So x to the 1st times x to the 6th, or x to the 5th, sorry, makes x to the 6th. Notice I kept the base the same and added the exponents. Next one, I'm going to give you the answers, then we're going to talk. 2 to the 4th, so that's a power, being raised to another exponent. Y to the 2nd being raised to the 4th. Negative 3 to the 3rd being raised to the 2nd. So what math operation do you end up doing when you have exponents? So if you have an exponent and an exponent, or sometimes referred to as a power raised to a power, anytime you have an exponent raised to another exponent, you multiply. Let's try a couple of these. So to evaluate a power of a power, multiply the exponents. All right, here we go. X to the 2nd raised to the 5th. Multiply the exponents, I get x to the 10th. 3 to the 4th raised to the 5th. Makes 3 to the 20th. So that's exponent rule number 2. So when multiplying like base items, add exponents. When have a power of a power, so an exponent raised to another exponent, would multiply the exponents.
Third exploration. I have more than one item in each of these parentheses. Now let's talk about it.
Anytime you have more than
An exponent. And what's in the parentheses is considered a binomial. So that is a key little situation there. It's a binomial. Anytime that occurs, each item in the parenthesis is raised to that exponent. So what do you think the parentheses mean to this example? Sorry for the small interruption there. What do the parentheses mean? It means that both items in the parentheses is raised to the power. Now, for right now, everything that's in the parentheses is going to be a binomial. We'll talk about later what happens if what's in the parentheses is a binomial or a trinomial or something like that. So, to evaluate power of a product property, to evaluate the power of a product, take each item in the parentheses raised to the exponent. Now, this does not work for this one. Okay? That is a binomial. So when I talked on the previous page that we're going to talk about that later. X plus 2, anytime there's an addition or subtraction sign between terms, that is a no-no, and we need to make sure we do that differently, and we are not ready for that yet. So this one we can use 2 squared and x squared. So again, both items in the parentheses. It's kind of like distributing, but I hate to say that. Okay, but both items in the parentheses are raised to the exponent. So this is a kind of an overview of everything. So this has a little bit of everything. 4 to the second, 4 to the sixth. Bases are the same. I'm multiplying. I'm going to add the exponents. Next one, -7 to the sixth and -7 to the first. I add the exponents. Exponent raised to an exponent. Power to a power. I multiply the exponents. So -5 to 12. The last one, if you have more than one item in a parenthesis raised to an exponent, both items are then raised to that exponent. More practice. X to the second, x to the third, x to the first. Remember to put a little 1 there, probably will make more sense to you. Anytime you're multiplying like-based items, add their exponents. Now, this is a no-no. Don't touch that. But I do have an exponent raised to an exponent, so I can do that. This one, okay, we're going to combine a couple things here. I've got -6 to the second. Now, anytime you're raising a negative to a power, make sure you put it in parentheses. Power to a power makes n to the sixth, n to the fourth. And because n to the sixth and n to the fourth are the same base, I can add their exponents. Next one. So I've got -3. Remember, anytime you're taking something, a negative to a power, please make sure you put it in parentheses. It's equal to 10. And then I have a -2 and a t to the sixth. So there was nothing on the outside there. So I still have a -3 to the second times a -2 and then a t to the 16th. Now, later on in the chapter, we're going to go ahead and anytime we have numbers, we're going to go ahead and multiply those or evaluate those. But for right now, we're leaving everything with exponents. Now, next one, the negative sign stays out in front. So now I've got -1 to the 5th, x to the 15th, y to the 20th. So there's the first parenthesis. I've got x to the 10th and y to the second. So I got a -1 to the 5th, x to the 25th, so I'm going to add the exponent, y to the 22nd. Now again, later we're going to talk more about evaluating our numbers. Let's because to be honest with you, that is just a positive 1. So the back of the book might give you that answer, because -1 to the 5th power is -1, and -1 times a negative is back to a positive. So not sure, depending on how your directions go, whether or not you're going to evaluate all numbers. You try this next one. All right, welcome back. I got a -3 to the second, an x to the second, a y to the second. And so the -3 to the second, x to the 5th, because I'm going to add the exponents, y to the 3rd. I will leave it like this answer. If they want you to go ahead and evaluate, -3 to the second would be +9. So it all depends on whether or not they want you to evaluate the numbers or not. All right, homework assignment tonight. Please make sure you talk to your teacher, check your Google